Okay, 8th graders, we've been working on probability, and today we're going to talk about a couple of things. First of all, what independent events means, and then how to calculate something happening in a row. Remember, Aiden, when you got double sixes yesterday, when you were rolling dice, followed by double sixes. Yeah. And we said that the chances of that happening are 1 out of 6 times 1 out of 6. Because those are independent events that happen in a row. And when you do that, when you have that, or to find that, you have to calculate the independent events of one times the independent events of the other. Okay? So that was really cool. What was that? 1 out of like 46,656 chances.
Wow.
Yep. 1/6 times 1/6.
If she had rolled,
Or I'm sorry, 136 out of 136. Yep. So, what we're talking about in that case are independent events, because when you're rolling dice, if the first roll does not affect the second roll at all, does it? It doesn't reduce the chances. If you get double sixes, does it reduce the chance that you're going to get double sixes again? No. No, it's the same probability, right? If you flip a coin, there's 1 out of 2 chances to get heads, right? What are the chances that you would get heads 3 times in a row? 1 out of, nope, 1 out of 2 times 1 out of 2 times 1 out of 2. So 1 out of,
1 out of 2 times.
no, 2 times 2 is 4, times 2 is
Oh, right.
8. 1 in 8 chances to get heads 3 times in a row. Okay? Now, flipping a coin is another example of independent events. Because if you get heads one time, does it mean that your chances of getting heads the second time are less? No, they're exactly the same. 1 out of 2, right? Right?
you put tape on it, then.
Yeah, but that's not fair. Now, dependent events, the opposite of that, would be if you had, for example, I've got 12 chips in here, okay, of different colors. So write this down. There's 3 yellow ones. There's 3 yellow ones. There are 5 green and 4 blue. Okay? 4 right in here. Okay? 3 yellow, 5 green, and 4 blue. Now, what are the chances on the first pull, on the first time, that I'm going to pull a yellow one? What are the chances that I would pull out a yellow chip? Not 1 in 12. There's 12 total, right? How many chances how many yellow ones are there? 3. So it's 3 out of 12. The probability is 3 out of 12, right? So we reduce that to 1 out of 4. All right? So let's say that I pull. Who wants to pull the first one? Of course, Dylan. Oh, it's a green one. All right? So we pulled out 1 green one. Now, if I leave that green one out, how does that change the probability that I'm going to pull out a yellow one now?
It reduces what?
Does it go, the probability goes
higher.
up, doesn't it? Because instead of 12, now there's only 11. So without replacement, it's called. So write this term down, without replacement. If we pull out one green one, that's reduced to 4. Now the chances of pulling out a yellow one are 3 out of 11. Right? Now, let's pull another one out. Keyshawn? A blue one.
3 out of 10.
So now, chances of pulling a yellow one are
Higher.
That's
3. Now they're 3 out of 10,
a 1 to 3 chance.
right? Not quite.
No? Almost 1.
Almost 1 to 3. It's a 30% chance instead of a 33% chance, right? So this is without replacement. What would with replacement be? What would that mean?
Adding another chip in.
Adding the
Get back.
chip back in. So if we pull one out and we put it back in after we pull it, then that's called with replacement. Okay? It keeps the total the same, doesn't it? Yep. So now what's the probability of pulling out a green one without replacement? We pulled out a green one, we pulled out a blue one. What's the probability of our next one being green?
4
We pulled these out without replacement.
4 and 10.
4 out of
Yeah, because you have 6.
4.
Then 4 is 10.
out of 10. What percent is that? Multiply both, or
Well,
change this to
40%.
100. That's 40%. Good, Keyshawn. That's 40%. Okay?
Mr. Marks, if she had rolled another 12, it'd be a 1 in 1,679,616 chance.
Wow.
Wow.
Amazing.
Oh.
Okay?
We don't get the big one?
So those are called, that's what with replacement or without replacement means. Okay? Now, when we pulled these out and we left them out, was the next one an independent or dependent event? It was dependent on what happened, right? Because what happened changed our probability. So those are dependent events, right? If we leave them out. If we put them back in, then the probability or the total stays the same, and those are independent events. Anytime the results change the next time, those are dependent events. Okay? Then how would you find it independent events in a row?
Just put them back in every time.
Yep, or multiply the probabilities. Like before, multiply the probabilities. 1/6 times 1/2, or 1/36 times 1/36. Okay? So that's what you're doing today. That's what this lesson is about. Dependent and independent events. Okay? When one affects the other, then they are dependent events. As long as you didn't replace it. Does that make sense? All right.
That would be a sign.
Okay, we're gonna play a game next.
Why not? Yay, yay!